Continuing with logic and truth tables, this is lesson 3.2, compound statements and connectives, part 2. Thanks for joining us. Compound statements and connectives, so learning intentions. The students can express compound statements in symbolic form, and the students can express symbolic statements with parentheses in English. Warm-up. Let P and Q represent the following simple statements. P is I study, Q, I pass the course. Write each compound statement below in symbolic form. So it says I study, that is P, or, there's our mathematical symbol for or, I pass the course, which is Q. So it is P or Q. I study is P, and there's the mathematical symbol for and. I pass the course, which is Q. So it's P and Q, symbolic form. Let P and Q represent the simple statements. Okay, we're continuing on, same ones we had before. We're on part C. I study is still P, or I do not pass the course. So we're negating Q. So it's P or not Q. If I do not pass the course, so we're negating the Q here, then I did not study. We're negating P. And the if then gives us that arrow. That's the connective that we have. So not Q implies not P. Continuing on with the warm-up, same simple statements. I study and I pass the course. So if I pass the course, which is Q, then I studied, P. And it's an implication. Q implies P. Let's see about F. I do not study, so that is negating P, and there's a mathematical symbol for and. I do not pass the course, so we're negating Q. So it's not P and not Q. If and only if statements. If a conditional statement is true, reversing the antecedent and consequent may result in a statement that's not necessarily true. However, some true conditional statements are still true when the antecedent and consequence are reversed. If a person is a teenager, then that person is 13 to 19 years old. We used this before. If a person is 13 and 19 years old, then the person is a teenager, which is also true. So the original condition, conditional statement, and its converse are both true. Rather than deal with two separate conditionals, we can combine them into one biconditional statement. A person is a teenager if and only if that person is 13 to 19 years old. If P and Q represent two simple statements, the compound statement, P if and only if Q, is symbolized with this, which has the two-way arrow because it goes in both directions, if and only if. So that's P if and only if Q. Compound statement formed by connecting statements with if and only if are called biconditional statements. If and only if example 1, the table shows the word set, has 464 meanings. Wow. Making it the word with the most meanings in the English language. Let P and Q represent the following simple statements. P, the word is set. Q, the word has 464 meanings. We need symbolic forms. The word is set is P. If and only if is a two-way implication, arrow on both ends. If the word has 464 meanings, which is our Q. So P, if and only if Q. The word does not have 464 meanings, so we are negating Q if and only if, two-way implication. The word is not set, so we're negating P. So that's not Q if and only if not P. Another one, example 2. Now the word is run. And the word has 396 meanings according to that table. So we need to write compound statements in symbolic form using those simple statements up above. The word has 396 meanings. That is Q. If and only if, our two-way arrow. The word is run, which is P. So Q, if and only if P. The word is not run, so we're negating P if and only if. The word does not have 396 meanings, so we are negating Q, not P, if and only if, not Q. Common English expressions for P, if and only if Q. So that is with the phrase if and only if, and we are using the teenagers, and the person is a teenager, a person is 13 and 19 years old as our example again. So a person is a teenager if and only if the person is 13 to 19 years old. Another way of saying this, Q, if and only if P. So a person is 13 and 19 years old if and only if that person is a teenager. On this one, we are writing it into two separate forms. So if P, then Q, and if Q, then P. So if a person is a teenager, then the person is 13 and 19 years old. And if a person is 13 and 19 years old, then the person is a teenager. Now the necessary and sufficient part. P is necessary and sufficient for Q. So being a teenager is necessary and sufficient for being 13 and 19 years old. We can do it the other way. Q is necessary and sufficient for P. So being 13 and 19 years old is necessary and sufficient for being a teenager. Statements of symbolic logic. So negation. So that is not P, or it is not true that P, depending on the situation. Conjunction is P and Q, or P but Q. Remember, there was actually a whole list of things we could use for that. Disjunction is P or Q. Conditional is P implies Q. If P, then Q. P is sufficient for Q. Q is necessary for P. Biconditional statement is a two-way implication. There we go. P if and only if Q. P is necessary and sufficient for Q. Symbolic statements with parentheses. So parentheses in symbolic statements indicate which statements are to be grouped together. Example 1, we have our negation, but we're negating P and Q. So we're negating the whole thing. So it means the negation of the entire statement, P and Q. We read this as it is not true that P and Q. And that's where that not true phrase is going to come in with our parentheses. Example 2, that's not in parentheses. So not P and Q means that only statement P is negated. So we read it as not P and Q. Unless parentheses appear in the symbolic statement, the symbol for not negates only the statement that immediately follows it. Example, let P and Q represent the following simple statements. P, she is wealthy. P, she is happy. This time, we're writing each of the following symbolic statements into word form. So that's different than what we've been doing. In my math lab, these are going to be multiple choice, but make sure you read them carefully so you are selecting the correct answer. So we are negating in part A the P and Q. So here we go. It is not true that she is wealthy and she is happy. Next one, we're only negating the P. So she is not wealthy and she is happy. Now we have a negation of P or Q. So it is not true that she is wealthy or she is happy. Another situation, P, he earns $105,000 yearly. Q, he is often happy. So write each of the following symbolic statements in word form. So we are negating P and Q. So it is not true that he earns $105,000 yearly and he is often happy. In part B, we're only negating Q, which is the he is often happy. So he is not often happy and he earns $105,000 yearly. In part C, we're negating a conditional statement, an if then. So it is not true that if he is often happy, then he earns $105,000 yearly. Symbolic statements. Statements to group together. If Q and not P, then not R. Okay, on the next one, you're grouping together a different situation. So if you take out the grouping symbols, both rows look the same, but it makes a difference where the grouping symbols are. Many compound statements contain more than one connective. When expressed symbolically, parentheses are used to indicate which simple statements are grouped together. When expressed in English, commas are used to indicate groupings. Let P, Q, and R represent the following statements. A student misses lecture is P. Q, a student studies. R, a student fails. And we need to write each of the following symbolic statements in word form. We are grouping together Q and not P, and then we are inferring not R. So if a student studies and doesn't miss lecture, comma, then a student does not fail. This is the end of compound statements in Connectives Part 2. Thanks for joining us.